Welcome one and all. So in this lecture or in this short video, I will discuss that what is a perfect number and a very interesting fact about about perfect number. So a perfect number, it is a positive integer that is equal to the sum of its positive proper divisors, excluding the number itself. Example, actually 6 is a perfect number. How? Its divisors are 1, 2, 3. And if we add these divisors, excluding 6 itself, then we get the 6. Okay. So making it a perfect number. Okay. So here the first few perfect numbers are 6, 28, 49, 496, and 8128. So 28, what are the divisors of 28? 1, 2, 4, 7, 14. And if we add these, we get 28 itself. Okay, similarly, 1, 2, 4, 8, 16 up to 248. These are divisors of 496. And if we take the sum of all these, we get nothing but 496. And similarly, one can verify the same thing for this number 8128. Means these are our first few perfect numbers. Now, there is a very interesting question that suppose we are given some numbers. Say here we are having four numbers. So out of these four, which one is a perfect number? Now it seems that it is a very long procedure to check that which one of these is a perfect number. How it is a long procedure? Because first we have to find out all the divisors and then further take the sum of all the divisors and then further we can check or verify that which one of is a perfect number. But this question has a very nice, very interesting shortcut. And the shortcut, it goes by the name of Euclid-Euler theorem. So here is the Euclid-Euler theorem. And this theorem simply says that all even perfect numbers, they can be represented by this formula. So means here, our all even perfect numbers, they are of the form 2 raised to power p minus 1 into 2 raised to power p minus 1. So this is the form of all even perfect numbers where what is p? P is a prime number such that this number 2 raised to power p minus 1. This is also a prime number. I repeat, p is a prime number so that this number 2 raised to power p minus 1. This should also be a prime number. This is very important here. And this type, the prime numbers of this type, 2 raised to power p minus 1, means 2 raised to power p minus 1. It should also be a prime number, where p is also a prime number. They are known as Mersenne primes. Now, in order to understand this theorem, let us consider the following geometric progression. Actually, nothing. This geometric progression, they are the powers of or exponents of 2. So here it is 2 raised to power 0, then 2 raised to power 1, 2 raised to power 2, going on. And here we will use this fact that sum of the powers of 2 up to p minus 1, it is nothing but 2 raised to power p minus 1. And obviously this formula is coming from the formula of geometric series which is given here. So let us start now. So first I am taking the sum of first two terms of the given geometric progression, means 1 plus 2. Now 1 plus 2, this is equal to 3 and 3 is a prime number. 3 is a prime number. Okay. And now this 3 into just the previous number 2 means 3 into 2, it gives us 6 and 6 is the first perfect number. Now let us carry on. So 1 plus 2 plus 4 means the sum of first three powers of 2 and this is giving us 7. 7 is also a prime number and 7 into 4 means just the previous number. So 7 into 4, this is giving us 28, the next perfect number. Now, once again, let's carry on. So 1 plus 2 plus 4 plus 8. And this is equal to 15, but 15 is not a prime number. 15 is not a prime number. And now also 15 into 8, just the previous number, 15 into 8, this is 120, and 120 is not a perfect number. Okay. So let's carry on further. So 1 plus 2 plus 4 plus 8 and plus 16. And this is equal to 31. And 31 is a prime number. And 31 into 16, this will give us 496. And 496 is also a perfect number. So here we can see, anyone can see that these perfect numbers, they are following a certain trend. Okay, so just to understand this trend, so let's continue this thing. So 1 plus 2 plus 4 plus going on actually now up to 32. Up to 32. So this will be nothing but 63. And 63 is not a prime number. 63 is not a prime number. And moreover, 63 into 32. 63 into 32. This is 2016, which is again not a perfect number. Now 1 plus 2 plus 4 plus going on up to 64. And this is 127, and 127 is a prime number. And 127 into 64, which is 8128, which is 812 is the next perfect number. So one can see, very well can feel that perfect numbers, they are following a certain trend. Now, what trend is being followed here? Means the perfect numbers, they are following what trend? Now, if I take up this case here, so here, what was the value of P? So actually this 4, it is 2 raised to power 2, which is corresponding to 2 raised to power P minus 1. So I am referring to this formula. So here, what is the value of P? If P minus 1 is 2, so obviously P minus 1 is equal to 2, means P must be equal to 3. Now, if I check the right hand side, so right hand side, it is actually 2 raised to power 3 minus 1, which one can easily verify. Now, once again, let us check the same things, same trend here. So here it is 64. 64, actually it is 2 raised to power 6. And this is corresponding to nothing but 2 raised to power P minus 1. Means, what is P minus 1? It is 6. Means what will be P? Nothing but 7. Now one can check the right hand side. So it is 2 raised to power 7 minus 1. So once again, I am referring to the same formula. Even one can verify here also. Here once again, this 16, it is nothing but 2 raised to power P minus 1. Actually, P minus 1 is 4. So what is P minus 1 is 4. So what is P? It is nothing but 5. Now, once again, one can check this side, 31. So what is this 31? So this 31, it is 2 raised to power 5 minus 1. Okay. So this trend is here, and how we were getting the perfect numbers. So we were getting the perfect numbers by multiplying this 2 raised to power P minus 1, means the number on the right hand side, the number on the right hand side. And we are multiplying this number by what? 2 raised to power P minus 1. Okay. So this trend is being followed here. But in certain cases that we have discussed, this was not giving us a perfect number. What were those cases? Those cases were 15. This was the one case, 15. And the another case was of 63. So why they didn't give us this 15 and 16, 63? Why they didn't give us the perfect number? The reason was very simple, that 15 and 63, they are not prime numbers. although they are of the form 2 raised to power p minus 1. They are of this form 2 raised to power p minus 1, but they are not giving us perfect numbers. Actually, why? Because they are not prime numbers. So here there is the list or table of first nine Mersenne prime numbers and perfect numbers. So one can very well see the first prime number was 2. So the first Mersenne prime, it is 3. And what is the perfect number? It was 6. So one can very well verify all these, that for the first entry means for this one, this row, what is the value of P? The value of P is 2. So what is the value of 2 raised to power p minus 1? It is nothing but 2 raised to power 2 minus 1, which is 3. And what is the value of this number? 2 raised to power p minus 1 into 2 raised to power p minus 1. So obviously, what is this value? It is 3. And what is this value? 2 minus 1. So it will be 3 into 2, which is nothing but 6. Similarly, the next perfect number was 28, and this was the next prime, Mersenne prime. The next perfect number was this, and next Mersenne prime was this 31, and similarly going on. Now, someone may be surprised to see that after 7, it is 13. After 7, it is 13. Means 11. This prime number P, it is missing. Means P equal to 11, it is missing. Why it is missing? The answer is in the same thing which I had just pointed out, that 2 raised to power P minus 1, it should be a prime number. Okay. So if you put p equal to 11, 2 raised to power 11 minus 1, actually 2 raised to power 11 minus 1, sorry, 11, it is 2048, and minus 1. So it is 2047. Now this 2047, it is not a prime number. Actually, it is a composite number. Actually, the factors of 2047, they are 23 and 89. This one can very well see. So that's why 11 is missing. Now then 17, 19. Now once again, one can very well see that many prime numbers are missing here. For example, here 23 is missing and even 29 is missing here. So once again, one can very well verify why 23 and 29 are missing. The answer, that if P is 23, then 2 raised to power P minus 1, which is actually 2 raised to power 23 minus 1. Actually, this is not a prime number. It is a composite number. Similarly, for p equal to 29 means 2 raised to power p minus 1. That is 2 raised to power 29 minus 1. It is also not a prime number. Okay. So after 19, it is 31 and then 61. So these are the corresponding Mersenne primes. Please mind, these are what we call Mersenne prime numbers. And this side, it is nothing but our perfect numbers. At present, there are 51 known perfect numbers, and there are only two perfect numbers from 1 to 100, which are 6 and 28. The latest perfect number, which was discovered in the year 2018, it has these many digits. Please mind, an interesting fact. So now, actually, there is a great internet Mersenne prime search which is going on. Its short form is GIMS. Actually, you can see there is a particular photograph here. Actually, this is the person Mersenne, Marin Mersenne. Okay, he was a French monk. He was a French monk who studied these Mersenne, these primes in the 17th century. Okay, so here This one, it is the new largest known prime number, actually Mersenne prime number. Okay, so one can search on the internet www.mersenne.org, and one can search about the biography of this person, Mersenne, Mersenne. So I hope that one must have found this video to be interesting, and mathematics is actually full of such interesting facts. Thank you. Take care. Keep learning, and learning gives us a joy.